Okay, we're doing a little extra review session on logs because there's a retake this week. There were a lot of kids that had trouble on the last logs test. And so here are some extra practice problems. Just a 2-second review here. We just did a subtract one before I started the recording. And the problem started like this. We knew it was a subtract, so we turned it into this. We condensed this part right here. And then we did a rewrite. And the rewrites are really handy. It happens a lot on the test, where if it's in log form, you make it exponential form. You say 3 to the 4th equals 4x over 7. And then that was the red writing in here. And then we multiplied both sides by 7/4. Final answer came out to this right here, because x was alone over here. All right, that's kind of a rush job. Watch this next one. Here, we should do the same thing. Combine this part. Did you guys know to do that? And did you get log of 5x times 9? Good, because this is a add. That turns into a multiply. Equals 4. And now, what base is this thing? Welcome, base. No problem. Just find a spot. Base 10. So it's 10 to the 4th equals that stuff. 10 to the 4th equals 5x times 9. I could just say 45x, couldn't I? Because 5x times 9, 9 times the 5 would be 45. So 45x. And then x is almost alone. So 10 to the 4th is a 1 with 4 zeros. And that's 45x. And then I just divide both sides by 45 and I'll have it. X equals that. Do you get that one? Yep. I'll pause it for a second. Oh, you mean, can you leave your answer like that? Yes, but all depends on how tough your teacher's going to be on reducing. Now on that one, you can reduce it. It's kind of nasty, but you could. You could say 5 goes into both of them. 5 goes into this one 9 times. And 5 goes into the top one 2,000 times, I think. So 2,000 over 9 is a better answer because it's reduced. All depends on how tough your teacher's going to be. You can always bring your test up and say, do I need to reduce this farther? It's a reasonable question. Especially on this test, it's hard to tell sometimes how, the answers can be messy. How messy can they be? All right, let's try another one. 5 to the 2x equals 25 to the 2x plus 3.5. There we go. Okay, on this one right away you should be thinking, if the 5 and the 25 were written with the same base, then this would work a lot better. So you replace that 25 there with what? 5 to the 2nd. That way now they both have the same base. If you can get them so they both have the same base, then their exponents have to be equal. Because logically, if I have something like 8 to the x equals 8 to the 15, well, duh, this has to equal this. So now this has to equal that. Now it's really tempting to do this part wrong. You want to multiply that times that and that times that. So I'm going to get 2x equals 2 times the 2x is 4x, and 2 times the 3.5 is 7. And now it's just solving a simple equation from there. Yes, sir?
Couldn't you just divide each side by 2 after you cancel it?
Yes, you could have done that, but I kind of like getting it, this also gets rid of the decimal by doing it this way. So either way it'll work. So now I'm going to take away 2x from both sides. And I get 0 equals 2x plus 7. I could have done that a faster way too, but I would have had a negative involved, and I like to not. So now I'm going to subtract 7, negative 7 equals 2x. I'm almost done. And x has got to equal negative 7 divided by 2. Negative 7 halves. All right, so from there it was just simple algebra. To get it to the simple algebra thing, though, I had to know that I make my bases the same. And once I make the bases the same, this will have to equal that. All right, another kind of problem you got to know how to do. 12 e to the 4x is equal to 36. Now on this one, people that have listened to me enough about this probably say, well, it doesn't have a log in it, so I should probably rewrite it so it's got a log in it. And then they rewrite this and then they get it wrong. Why can't you rewrite this yet? Got to get rid of the 12. If I divide by 12 on both sides, now I've got e to the 4x. Now I can rewrite it. You can't rewrite something that has got junk around the base. The base has to be clear. Okay, so that e can't have stuff on the over here, can't have stuff over here. It can have a power, of course, but it can't have junk around it. Okay, so once I got it down to just e to the 4x, now I can rewrite it. Everybody try rewriting that and let me see what you get. I want to actually see it on your paper so I can see if you know how to rewrite. Because if you don't, I got to help you with that because it's huge. It's good. Where is it? Okay, what we need to do is put a log into it. Oh, wait, I see. Wait a minute. You maybe just have it on the other side of it. Base. You just have yours backwards than the way I usually have it, but it's totally okay. What do you mean rewrite it? All right. Rewriting it means that you want to rewrite that exponential with a log in it. It's got to be log something. If you don't know how to do that, we got to help you with that. And you've got it right. Good job. And okay, you need to learn this part. Now I'll pause for a second to help you with that. And yes, you even went the last step. Good job. All right, good. Okay. Okay, so now to finish this one off. Is x alone here? No. It's close, though. I just have to get that 4 off of there. So how do I get this 4 off of here? Divide by 4 on both sides. And then this cancels, and x is alone, and there's my answer. Let's do one more like that. 5e to the 2x equals 500. All right, so your first thought should be get rid of the 5. Divide by 5. Where did it go? That's weird. There it is, okay. Divide by 5, cancels. E to the 2x equals 100. Then, you got to rewrite. It doesn't have a log, so I go to log form. If it had been a log, I'd rewrite it and put it in exponential form. But anyway, this is an exponential form, log base e, also known as ln, because log base e is ln, of 100 equals 2x. And then, what do I do now? Divide by 2. There you go. And there's your answer. Raise your hand if you had that one right. Okay, good. I think we can move on past that then. Next kind. Log base 5 of x equals -1. If you know how to rewrite, these are simple. Tell me. No. Tell me what to write. 5 to the -1 equals x. There you go. That to the that equals that. And then you did do one extra step there. What was this? Was this really?
The negative makes it 1 over.
1 over 5 equals x. Very good. Get that? Raise your hand if you're good with that kind. Okay.
Did you get that wrong if you don't put it 1/5 equals x?
It depends on your teacher, but I might have taken that, but you should know how to do that. If it's a -1 power, you just flip it over. That's all there is to it. It's easy. So don't even have a question, just always do this, and then you'll get it right. Do you get that? If anything to the -1, just flip it over. So if I had 2/3 to the -1 power, that's equal to 3 over 2. If I had 5 to the -1, it's 1/5. If I had 15 to the -1, it's 1/15. Okay? All right. So moving on, let's try this one. Log base 5 of x is plus log base 5 of x minus 24 equals 2. All right. Once again, this part right here needs to get scrunched together. Come in for some extra practice? Extra practice? Okay, good. You're in the right place then. If I squish these together, it's called condensing, and I can rewrite these two logs as just one log. So I say log, it's still the same base, log base 5. And when you're taking one that's a plus, you put them together as a multiply. This part and this part are now multiplied. X times x minus 24. And it still equals 2. Same thing over there. Okay? Now, this is crucial. Once again, a lot of kids want to think, oh, I'll just drop this stuff and I'll say it's a quadratic and I'll solve from there. You can't do that. You can't just drop a log unless you have them on both sides. If you had one on each side, then you could drop the log. But we don't. So, once again, it's a rewrite. That to the that equals that. That's the step that so many people forgot on the test. They tried to just cancel that log and you cannot. If there's a log on both sides, you can. So it's 5 to the second equals x times x minus 24. It's a weird looking 2, but it's a 2. 5 squared is 25 equals x times x minus 24. And then I'm going to go 25 equals x squared minus 24x. You understand where I'm going with this? And then I say equals, what am I doing? Minus 24x minus 25. And then it factors, because usually we set these up so they will factor, because it's so much nicer than having to use a quadratic formula. And then it's a 25 and a 1 makes a difference of 24. Then it's just a matter of figuring out which one of them is negative. Which one is negative? 25. And then this is positive. And then I have my two answers. X equals negative 1 and x equals 25. Oopie. 25, not 24. Okay, now this is crucial. Two things. About one kid in every class would take this and then substitute logs back in. That's a whole different kind of problem. Okay, on this problem, we didn't substitute, let y or u equal log of x. We didn't do that thing. We didn't take the log out and put an x in. It's not one of those kinds of problems. So you don't substitute it back in at the end. We are done. The only other thing you got to do is check your answer. Because a lot of people got this problem wrong because there's an extraneous answer. And there is again. Look at the original problem and see which of these two answers doesn't really work. You already got it? Good, just hold on a second. So 25 or negative 1 doesn't work. So if I put it back in, if I put in a 25 here, does that cause anything to crash? No, it seems to be okay. In fact, this one would end up being 2 because 25 could be written as 5 squared, and then I got a 2 there, plus the other one would be a 1 there, and anytime there's a 1 there, you know what the answer is? 0. And so this whole thing becomes 2 plus anytime there's a 1 in this part called the argument, then it's a 0, and then it equals this 2 here. So it worked. Perfect. So 25 is fine. So what's the problem? The other one. Why can't it be negative 1? Hold that thought just one second. Okay. So back to where were we? We were saying that negative 1 wouldn't work. Do you know why? I hope you know that you can't have a negative in that spot. Right away, I don't even have to check over here. If this thing has a negative in the argument, whole thing crashes. Can't work. Okay? So that is why the negative 1 is extraneous, and I cross it off. Does that mean anytime you ever have a negative for an answer, it's wrong? No. It depends on where it is. But if they're asking you to stick a negative here, then you can't do it. And if you're asking you to stick a negative right there, again, you can't do it. It's not allowed by logs. Right? So that's why this is an extraneous answer. Okay. Next kind of problem. Log base x of 16 equals 4. Easy peasy if you know what to do. Now, don't make the dumb mistake, though, that so many people make. Did you say x to the 4th equals 16? That's not a dumb mistake. That's a good start. Right? Okay. So then what do I do next? How do I get the x alone? Put it to the 1/4. So x equals the 4th root of 16, which is 2. Wrong. Yes. How many of you remembered that it was plus or minus? All right, 3 of you. Now, the rest of you would have got it wrong. Why? Why is it plus or minus? Because anytime you take a square root or a 4th root or a 6th root or an 8th root, any even root on both sides, you gotta bring in the absolute value, and the absolute value of x is 2, and then you get the final answer then of x equals plus or minus 2. Okay? That's a square root. You don't think of it as a square root. It's just a 1/4 power, but it's like a double square root. It's a 4th root. Okay? All right. So that's a really common mistake I'm sure a lot of you probably made on your tests. There was one on there where you had to have plus or minus. Okay, next one. Let's try this one. Log base 3 of x over 5 is equal to log base 3 of 25. Any thoughts? Logs cancel, yes. When it's down to just a plain, there can't be anything here, and there can't be anything over here, but if it's just a plain old log base something of something, there's no extra junk. And the same thing on the other side. There's nothing in front of it, there's nothing like after it, then this can just cancel this. And my answer is x over 5 equals 25. Okay, and then I multiply by 5 on both sides, x equals 125. Any questions about that one? All right, next one. 2 over log x plus log x cubed is equal to -5. I think it's a -5. Yeah. Okay. This is the hardest kind. This is a quadratic. And if you know how to substitute and do what's called a U substitution, that's what the calc teachers call it. I sometimes would substitute x, and Mrs. Richens would sometimes substitute y. I'm now changing over to substituting the letter u. It doesn't really matter. You just have to substitute something in for the logs. So you pick and say, I want to get rid of my logs, and I'm going to say let log of x equal, I'm going to say u. Okay? Just a variable, any variable. And now I can pull it out, but here's the tricky part. This one pulls out really easy, and I put in a u. But what do I do with that one? Put the 3 down in front. You are correct. Remember how there's a property that says that these numbers that are up as exponents can go down here? Well, we need to do that. So that now we've got a plain old log x, because that's what I substitute u for. I can't substitute the u in unless it's just a plain log x. So now this plain log x can come out and I can put in a u. And now I'm going to rewrite my equation. 2 over u plus 3u equals -5. And now I just solve this puppy. At the end, I'm going to have to do that substitution back in again, but for right now, it's just solve this. All right, so it's 2 over u plus 3u plus 5 equals 0. And now, do you know what's the next step? Yes?
Times u by everything.
Yes, you times everything by a u. Because you want to get rid of this fraction u thing, and now it's gone. 2 plus 3u squared plus 5u equals 0 times u is 0 still. Now it factors. This is why this is such a hard problem, because there's like 10 steps. Did you see the factoring already? Yes. You seem to be model student today. I'm just picking on you then.
3U.
3u. Should I put this plus 2 at the end? Would that make it easier to like... That's what way they usually are. Okay, go ahead.
Okay. Plus 1.
Plus 1, and the way you think the other one is.
U plus 2.
All right, now let me double check you. You check your firsts, and that should make 3u squared, and it does. My outside and my inside should total up to 5u, and it does. And my lasts, 1 times 2 makes a 2. It worked. Okay, so now, question about that?
That way, isn't it like 6 plus 1?
Oh, yeah.
Would be plus 2
Uh-oh.
plus 1.
I assumed he was doing it correctly, and it flowed so well. Okay, so you think I should put a 2 here then, Jay?
Yeah.
All right, 2 and a 1. All right, now I should double check that outside inside. Sorry about that. I should have been more careful. 3, you and I both made the same mistake in our head. 3 and the 2 makes 5. There we go. Okay, sorry, now we got them in the right spots. So then, you would have to equal negative... No, I don't think so. Here, in case you get stuck on that kind, what you do is you rewrite this at equal to 0. 3u plus 2 equals 0. 3u equals negative 2. U equals negative 2/3. Okay? On the other one, that one I can do in my head. U is negative 1. Yeah, can't write a 1 though. There. Okay, there's my 2 answers. And again, I'm not done. I got to do that substitution back in. Remember what I said at the beginning, let log x equal u. So here's a u, so it's really log x. And this, log x. And then is it done yet? No, because x isn't alone. So how do I get the x alone? I got to rewrite. The rewrite was on like 8 out of the 8 questions. Seriously, you got to know how to do that. Base 10. 10 to the that equals that. And so 10 to the negative 2/3 equals x. And on the other one, 10 to the negative 1 equals x. Hardest kind, guarantee you there'll be one on there. Okay?
Should you put the, it'll be like 1/10?
That is 1/10, just to be safe, in case your teachers are really strict. Yes. This one, though, there's no way you're going to know what that is. I don't know what the third root of 10 is, so I can't really do that one in my head. All right, so moving on. Freaked him out a little bit. Next one. We'll do another one that's kind of like that. And it's another way you could see the quadratic one. This is the last one we'll do, and I'll give you time to get to your classes. Log x squared. A lot of times they'll write it that way. Plus log x squared equals negative 1. See if you can handle this one start to finish. Do the u substitution, or y, or whatever letter you want, but u is what the calc teachers are going to use. Okay, I'm going to do the first part here. The u substitution. I'm going to let u equal log x. Or I could have said let log x equal u. Either way. Okay, so then I'm going to yoink this out and put in a u. Can I just tear this one out and put in a u? No, because I'll end up with a u squared there, so I can't do that. Got to put the 2 down there first. This comes down here in the front. Now I can substitute out, take that out, put in a u. Okay? So now I got a u here and a u there, so I got u squared plus 2u equals negative 1. Then I have u squared plus 2u plus 1 equals 0, and then I can factor that puppy, u and plus 1 and plus 1. Am I making any mistakes yet? Okay, and then I got to answer the same thing twice, which is kind of handy. U equals -1. Can I stop right there? No, I have to do the substitution back in. Because I cheated up here and substituted that in to make it simpler, I'm going to now have to pay the piper and substitute it back in again. Log x equals -1, and then this is really a base 10, and so it's really 10 to the -1 equals x, and then that's the same as 1/10. The answer is 1/10. Get that kind? All right. That's pretty much what you need to know for this test. If you want to do more practice, you can always look in your book at that section and do some odd ones. The answers are in the back of the book. All right. Good luck on your test.